How's it? And welcome to this video. It's going to be a slightly different video where we're going to be playing around with Azure and Terraform, which we have been doing over the last couple of videos. The reason for me recording this one specifically is that I have recently presented this as a user group, and I've had a couple of requests to share a recording for it, so I thought I'd record the whole thing as a video and upload that. If you are in the Durban area in South Africa, feel free to join on the user group. We're trying to have sessions at least once a month back in person again, so it'll be pretty cool to start seeing more people there. So briefly, if you don't know who I am, I'm a father, husband, also a DevOps specialist at Derivco, a triathlete and a Microsoft MVP. And as with everything else, my opinions are my own. So this session's largely, as I mentioned, going to be playing with Azure and Terraform. So you might ask, you probably already know what Azure is, might be wondering what is Terraform. Terraform is an open source infrastructure as code software tool that has been created by HashiCorp. Out of those words, you might be asking yourself, well, what is infrastructure as code? Infrastructure as code, plainly put, is you storing definitions for what your infrastructure looks like inside code. And you treat that the same way as you do any of your other source controls. So you do pull requests to it. You have branch policies to make sure that people can't just change main and all that other good stuff as well. So for this video, I have a demo repo. So if you go to my demo.org, devstarops-org / playing with Azure and Terraform, you'll be able to see all the code for today. And the code itself is broken up into different tags. So as we step through this, you'd be able to, from that repo, just switch to the different tags and you should get that latest version of what that code base looks like. For those different tags, if you want to see what changes were made for the video itself, you can just compare the one tag to the previous one, and that'll show you all the changes that you need to do that part of the demo. As I mentioned already, we will be using GitHub for this. As part of the demo, we'll also be creating a Azure web app that has an Azure SQL database backing it. We'll obviously be using Terraform because that's the big part of what this video is. And then also we'll be using Snake just to do some scanning on our Terraform templates to check for vulnerabilities. And obviously there's a whole bunch of other resources that will be in here, but those are some of the main ones that we'll be talking directly to. So onto our first demo. The first part of this is basically just going to show you what the starting environment looked like for the code base. So let's take a look at what that looks like. So this repo at the moment it's very empty, and currently does point to that demo org that I mentioned and that same Git repo. At the moment, inside main.tf, we have almost nothing. We basically just mention the Azure Arm resource provider that we're going to be using throughout this video. We new up some variables that we're going to be using, like the region and the resource group names and environment names, and then we output some variables as well. That'll be helpful for us when we see logs to see. Then we go and declare some variables for our local variable group and define where our backend is going to be. In our scripts folder, we've got a couple of scripts here, one of them being a create backend.ps1, and that has some variables at the top that define the same variables that for the sort of shell of our backend. And then it creates the storage accounts using Azure CLI. And then we have an init, plan, and apply, which have very basic commands in them that just handle those three operations for us with the correct local files. So to get started, we'll just cd to that scripts directory, and we'll run the create backend.ps1. As I mentioned, that's going to go and create the storage account for us using Azure CLI. Once we've got that, we can run the init, which is going to go and pull down the providers that we are specifically using. And then, although it's not going to do anything at the moment, because we don't have any resources, we can go ahead and run the plan, and then after that we can go and run the apply as well, just so that you can see the current state of the environment is sort of fully empty. Okay, so you can see that it didn't add anything or change anything or destroy anything as expected. And we head over to the Azure portal. We're going to be looking for the backend resource group. So there's that UG demo shared RG. And we'll just pin that to our dashboard so long. Just so it's easier for us to reference later on. If we look inside the containers, there's a tfstate container with our local tfstate file from the plan and apply that we did earlier on. Okay, so that's a very basic setup. The next part that I thought I'd do with the demo itself is sometimes you aren't able to get to your machine when you need to make some changes. So I set up a very basic code space setup. We'll just run through quickly what that looks like as well. So what we've got here is a dev container .json. We've just named it Terraform, included a couple of extensions that we thought would be useful for working with our project, and then we specified a post install script. In that post install script, we wait first to make sure that the network is up. After we know that the network is up, we go ahead and install PowerShell. We then go and install Azure CLI, and then after that we go ahead and install Terraform. In our task.json, those same scripts that we had in our scripts folder, we've just gone ahead and defined some tasks that represent those same scripts, so that it's easy for us to just push F1, go to tasks, and then run those specific tasks. So you can see here, if we look inside the init.bat, it's the same thing that we're seeing when we run this file, or that we've declared in this file, should I say. To test this out, in Codespaces itself, we'll go ahead and commit this code and push that to GitHub. And then once we go to GitHub, we'll go to code and switch to that demo branch that we'll be using for most of today, and then we'll just create a new code space from there. So once that's created, you can see obviously it's got the same, obviously it's the same code. You can see on the left every now and again there's a little loady thing that's happening, and that's because I'm signed in to GitHub with my GitHub account naturally, and my settings do sync using my GitHub account. So at the moment that's going ahead and installing all the extensions that we declared in our dev container JSON, as well as the extensions that are tied to my account specifically. and from inside this container JSON or dev container code space, same but different, we are able to run all our Terraform commands. So initially this breaks when we try and run it, and that's because we haven't done any auth yet. And because I can never remember the Azure login with the device code, I always run Azure login first, make that fail, and then I get the use device code link. And the reason for that is the Azure login redirects to localhost, and obviously when you're running in the code space, that's not going to get that request. So you use the login with device code, grab the code, go off to that link, and then sometimes you do have to go and accept pop-ups and everything else. So open that link, paste the code in, do your authentication, and then you should be all good and authenticated. So now we'll go ahead and just set the account to be the right one. So at the moment this is targeting my MSDN account, and I just needed that to target my one of my other sponsorship subs that I run my demos in. So just grab that subscription ID there. And then we'll just set that subscription ID in our Azure CLI. So you can see that now reflects my DevTech sub. Now we can push F1, run the init task again. You see that ran to completion. We'll go ahead and run the plan. So again, these aren't going to do anything while they're running because there is no actual changes there. But they should run exactly the same as they ran locally. And then lastly, we'll just go ahead and run the apply quickly. And then we'll go ahead and just stop this code space along. Okay. Okay, so now the last bit of sort of setup, if you will, is just going to run through the demo code itself. So there's nothing too serious here. We've basically just created a brand new .NET 6 application. It's an MVC web app. So if we do go to the terminal, go into that source folder, to the project, and we do run that. You can see we can open that properly. And then if you have ever made a new .NET app where it is doing individual accounts, you'll know that it generates a random database name by default. What we're going to do now is just test that connection. Naturally, when you do that, because it's not created yet, it'll ask you to apply migrations. Once you've done that, that actually creates your schema. And then you should be able to, after that, register an account and then log in using that account. And everything should be wired up properly. So this part's just us testing that database connection does work. As I said, if you are familiar with the app template, you'll know that it worked as soon as we had done the apply. But for anyone else who might not be familiar, we just clicked around a bit to show that. So we're going to go ahead and commit all that demo code quickly. And then that is done for the demo code. Now to actually start getting into the bits that you probably came here for, and that is the Terraform bits where we're going to be playing with Azure specifically. So what we got here is, to start off, is our resource group. So we're going to create a resource group called UG-Demo with the environment name -rg. From our main.tf, we've gone and added a random integer resource just so that we can randomly name our different objects that do need special uniqueness. Then in our network, we're naming that with the environment, that random integer demo network, and then we're creating a subnet that's available for the SQL Service endpoint as well as the Azure Web Apps. We're going to create an identity, so an application, again using the environment name and the random integer. We create a service principal for that and set the service principal as an owner of the resource group that we created earlier. And then for our SQL Server, we're going to create a random password, and then we will set the username and password, and we're going to just use some very basic settings. And then we set up a network rule that says that our web app can access the SQL box. Then we'll create an app service plan and then a web app inside of that plan using that random integer again. For our site config, we're going to say that this needs to be .NET 6. We're going to assign a user-assigned identity, and we're going to set this to be pretend it's a development environment, and that's just for ease of us not having to configure a DB deployment for this demo. And then we're going to set a connection string pulling in the variables off the SQL object that we created. So we're fetching the name, the fully qualified domain name, the login username, the login password, and all of that we're going to put together to form up our connection string. The database itself, we're just going to call demo and then again use those 2 bits of uniqueness to create the DB, and then we're going to connect that SQL instance to our virtual network that we created. So now that we've run through all the extra resources that we've made, we first need to go and run an init. And the reason for that is we are using new resources and providers, so that init will pull down those new providers. Now we can go ahead and run the plan to see what the changes would be. This should just be a whole bunch of adding new objects. So you can scroll through that if you want and see all the different changes. If you are familiar with this, you'll note there's just a bunch of pluses that says all the different resources that are being created. So once you're happy with that, you can go ahead and run the apply, and this will start making those changes to our Azure environment. Cool, you can see there that it's added 14 resources, hasn't changed any or destroyed any. And then the outputs that it gives us tell us what the URL is, and then some of those other useful bits and bobs that we asked it to output. At the moment, that website is just the standard Azure website, and we haven't obviously deployed our app to it yet. If we go to that local resource group, You can see all the different resources that are in there, but we'll just go ahead and pin that to our dashboard salon. And if you do see that number when this eventually loads, you can see that number does match the number. So this is that same website that would now have just been created for us. And I was going to connect to the SQL database, but it feels a bit pointless and very squirrely even for me. So I'll just go ahead and commit this code and be done with this part of the demo. Cool, so now that we've got our app and DB resources created, we obviously want to deploy that infrastructure, that environment as well. And to do that, there's a little bit of setup that we need to do as well, because we're going to use Terraform as much as we can to configure as much as we can so that there is no manual steps involved in any of our setup today. So let's take a look at what we've got here. There's a bunch of changes again. All of this is, well, most of this is GitHub. So there's us putting a GitHub token with a GitHub, referencing a GitHub user, which is just myself. Under the identities, we're going to give, we've made some owner role changes to that shared resource group, or to the shared storage. And we've created a service principal because the Terraform bits can't run currently using federated identity. And then the storage account, we're going to reference that storage account that we created earlier for the backend. In the GitHub repo folder, we're going to reference the repo that our demo runs under. And then we're going to create a federated identity for that specific repo for the specific environment that we're currently running as. And you can see that is for the dash app environment. So that's not local or like test or prod, it's local dash app. Then for repo secrets, this will be for all environments. We're creating the ARM tenant ID, ARM subscription ID, as well as we're passing in the same GitHub token ID as a secret that we're using locally. And then that token, we just give it full repo access and org admin read, or org read, sorry. Our repo environments that we're going to create is an infrastructure environment as well as an app environment. For the when it is production, we're going to say that it needs a reviewer of myself, and when it's not, there won't be a reviewer. If we look at the infrastructure environment specifically, we're going to pass it a client ID and a client secret. As I mentioned earlier, the Terraform bits can't work using the federated identity, so that client ID and the service principal that goes with it, well, yeah, need to both exist. And then for the app secrets, we're going to pass in some stuff that isn't really secret, but it is configuration because we use that random ID. So it's not saying that we would be able to hard code into our deployment script for where its target is. So we pass in the web app name, which it should be fairly known, but the resource group should be known, but the web app name won't be known. So just to keep it consistent, we pass them both in. And then we have the script added to our scripts folder, which just says run all of this, not for local. So obviously we're testing command by command locally, but if we wanted to, we can run this for all our environments locally as well. And then we've added in the test and production environment variables. So now again, because we've added some GitHub stuff, we need to go run that init again. Once we run the init, we can run the plan. And then locally, I haven't set my environment variable yet for GitHub. So I'll just go and get that quickly. So that same token that I showed earlier, I'm just going to go and grab that quickly. So I'm going to regenerate that, set it to 7 days, regenerate, copy that token out, and then just set that. So you'll notice there that I'm setting an environment variable that's tf underscore var underscore, and then the name of my variable. So Terraform, when it runs, will scan any environment variables with that prefix and then load them in automatically for you to your variables. So now if we run that, it should work perfectly fine. You can see there it's gone ahead and added 13 resources for us. And now while we're going to look at that, we'll just run this for everything that's not local. So we can go and generate that test and production infrastructure so long. If we go over to settings and we look at our secrets, you can see that under our repo secrets, those 3 different secrets that we created do exist there. And if you look under environment secrets, you can see the different secrets that have been created specific to those environments, as you would expect. So we go back to VS Code and we just let the other run complete. So that's basically everything we've showed already for our previous bit of demo for creating the local environment, but creating all that stuff for our test and production environment as well. So now if we refresh this page, as an example, you can see now we have stuff referencing the test environment inside our GitHub secrets. So you can go to that resource group, and similar to the other one, we'll just go ahead and pin that. We open that Epsilon, like the other one, that currently doesn't have anything deployed, but we obviously will get to deploying something to that in a little bit. So we just wait for the prod environment to finish running, and then we can go and check the same changes for prod. So there's those prod secrets that have been created. And the other change, if you remember, for production is that we said that we want to have a protection rule. So for that prod environment, you can see the reviewer is there for myself, where the test environment that was created doesn't have me as a reviewer. So let's go ahead and pin the production resource group as well quickly. And then just open up that site in a new tab, just so we've got it open as well. Cool, so all 3 of those are up and running. Obviously that we aren't able to test the database parts yet because it's just the static web app. But we'll go ahead and commit this code so long, and then move on with the next part. Okay, so everything we've shown so far has been manually run off my machine, or if we wanted to from the code space, because we did set that up. But with anything that you're developing these days, like that's not a viable workflow. You need to be checking in your code. When your code compiles and gets tested, that's when stuff needs to deploy. And as we mentioned with infrastructure as code, you want to be applying the same methods to how you deploy your infrastructure, to how you do your code. So we'll dive into that a little bit now and see what that looks like. So for this part, I've got a deploy workflow where we're going to trigger off main and demo, except if it's those paths. The main bit of work that we've got here is fairly standard. So we do a restore, build, test, and publish for our .NET app. We then publish those artifacts, and we publish a second artifact, which is the actions folder. Next up, we have a stage that will deploy our Terraform infrastructure. So that's using one of those actions. And then we have another stage that's going to deploy our app deploy. We set the congruency information here. It's more important for the infrastructure than the app. But again, for consistency in this scenario, we set them for both. If you look at our Terraform deploy action, it takes in a bunch of variables, which are all the ones that we would previously have needed when we were setting this up locally. So there's that client ID, client secret, client sub, the GitHub token. That all gets passed into those Terraform arguments. And then the app deploy does an Azure login. You can see there's no secrets being used here, and that's because that uses that federated identity that we set up to authenticate. And then it downloads the web deploy profile and then uses that web deploy profile to do the deploy directly afterwards. So we'll go ahead and commit these workflow changes in, and then test if our app manages to deploy it properly. This is running from our demo branch as we expected. So artifacts are published, so we know at least our code runs, which is good. We know it compiles, we don't know it runs yet. Deploying our infrastructure, that's already run locally, so that should run fairly fast. Our production stuff is skipped because we told that to only run off our main branch. So we'll just let our test deploy finish. So you can see there's that as where the subject claim that is highlighted is where it's getting the token for the federated identity. So that's GitHub reaching out and saying, I'm this repo, this environment. Is there someone I can authenticate with? And then on the Azure side, it says yes, that token is linked to this identity, and then that's who the author, how the auth works. It's a lot more complicated than that, but that's obviously a very high level of how that communication sort of plays out. So this is now running off the test site. So you can see there's that second tab that we created. So we had the dev, test, and production tab. And we're going to run through that similar flow to what we did locally. So you can see it asks us to apply migrations. And again, that's because we've set the environment to be the dev environment. If we hadn't done that, we would have had to have set up database deployments and a whole bunch of other stuff, which would have been a bit overkill for the purposes of demoing, not CI and CD of app code. Cool. So that is the workflows done. And now we can move on to some scanning. So having created a bunch of Terraform files, something that we don't have in this demo specifically because it's not about the code, it's about the infrastructure more specifically this time around. We don't have any code scanning, but if this was a real app, we'd most likely have some security scanning in there to make sure that we aren't missing obvious flaws in our software, and depending on what kind of scanning tools we're using, we could actually find some pretty advanced stuff as well. So for this demo, I'm going to specifically be looking at using Snake. And to do that, we basically just need a Snake token. And then that Snake token, I'm going to pass in as a repo secret as well. And then in our action, because now we're making changes to what the Terraform run needs, we need to pass those all the way through. So on our action, on our workflow, we're just going to go through and pass that. And then for our Snake infrastructure workflow itself, we're going to trigger off main and demo, and we're going to set up a schedule as well. And then this template file itself, if you go to GitHub and you say create new template, you get exactly this file. The only thing I've changed is that line 49 where I've put a dot. So by default, it has a named file. And I don't want to do a specific file, I want to do all the files. So I just change it to a dot. But we'll go ahead and commit this, and you can see what that looks like when it's running in action. So the whole idea of scanning your infrastructure is that you can try and see if there's like obvious ports that you're leaving open potentially, or some other misconfigurations that could leave your infrastructure vulnerable. And you sort of want to do scans for that before your infrastructure is deployed, because once it's deployed, you're obviously already at risk. Not authorized. Okay, so I haven't actually set that variable yet in GitHub. So I'm going to go ahead and run my local runner run first. And that's going to go ahead and set that token for me in GitHub. So I do have that set locally as an environment variable already. So we'll go run that locally with the plan and then apply. So that can get set in GitHub for the first time. With my current other setups, I have this actually as two repos, a sort of master repo that does high-level variables that does get run locally because that's its sort of way of being run. Runs as an elevated user as well for some identity stuff in Azure. And then the local repo runs as a specific user for everything that it does, so it doesn't have elevated access to the repo or Azure. You can see this run now, it did actually run, so it found some stuff there and let you know that some other stuff that did check, but it was all good. So we can go ahead now and look at the alerts. And I'm just going to switch this to the demo branch. So obviously I did run this previously off the main branch, but our demo was off demo. So you can see if we look here, that now says that it was off the demo branch. It did say it found it 7 hours previously, and that's when it would have first found it off this branch. Sorry, 6 hours. No, first detected 7 hours ago, and then ran 6 hours, 7 hours ago off the Snake branch, 6 hours ago off the main branch. And that's briefly how you set up your infrastructure, your scanning with Snake. So I do have a full other video on that. Pretty much with all these topics, the last sort of the month of August, I've been covering each of these topics in a little bit in more depth. So if you do want to take a look at that, you can go look at the previous video and see what that's all about. So the one thing I didn't show at the user group was Cloudflare integration. So, and the reason I specifically added it in now is because the previous demo that I did of this shows the Cloudflare integration with a Azure VM. And because the rest of this demo uses a Azure web app, the way you configure the Cloudflare integration is slightly different. So I thought it might be useful to show how that works for an Azure web app as well. There's a couple of gotchas that you have to worry about, but it removes all the sort of manual effort if you are used to setting that up yourself, either by scripts or manually. You would probably know some of those gotchas yourself. But yeah, let's take a look at what that looks like. Okay, so let's take a look at what we have here. So if we look at the main.tf, you can see that we had to include the Cloudflare provider, as well as this provider from Chilicat, which we're going to use to convert the Cloudflare Pearman private key into a PFX file. Then we pass the Cloudflare provider some properties, so we give it the user's service key as well as an API token, and then we just specify that we are using that PKCS12 provider from Chilicat. Then at the bottom, we just specify those variables that are going to get used from Cloudflare. You can see an extra one here that isn't mentioned above, and that's the zone ID that we're going to make the DNS changes for. So off and then into the Cloudflare file. So the first thing we do is collect the information that we need for the cert request. We then go and do that request for an origin cert. The next bit that we do is create the A record. So for that A record, we use that zone ID variable that we mentioned earlier. We also use a variable called DNS record, and then we reference a DNS A record set app IP address at the first address in that list. And the reason we need to do this is because the app service doesn't expose the IP address, so we end up using the DNS provider from HashiCorp, and that then gives us an IP address that we can pass on to Cloudflare. The next record that we create is a TXT record. So if you are familiar with setting up custom bindings with Azure Web Apps, you'll know that in order to do that, you also need to set up a verification record. So yeah, we go to that app service, which we've called web app, and then we grab the custom domain verification ID, and we just create a TXT record with ASUID with the same DNS record that we want to create. For this one, obviously this won't be proxied because it's a TXT record, but our A record will be proxied through Cloudflare. And then we create a random set of characters which we end up using for the password for our PFX file. So you can see that password gets passed in over here. Then we take in the certificate from our Cloudflare origin resource, as well as the private key over here from that request that we created earlier on. And then we just specify the DNS record and hostname variables as part of this file, which one gets used here and the other gets used as part of secrets later on. And then, as I mentioned, obviously we've added those new variables. So these two variables get added through our variables file, and the others get added through environment variables, and so they get injected because those are more secret. And we've got to make those same changes to all our environments. So when we're running this at local, it's going to be running at https local-ugdemo.devstarops.com. Test will be the same, but test instead of local. and then for production we drop that prefix, so it's just ugdemo.devstarops.com. And then the next changes we made were in the app service. So the starting bits here are just formatting, so sorry about that. But if we scroll down a bit, you can see the major changes that we made was we've created an app service certificate. So for that, we've referenced the PFX file that's come out of that utility, as well as the password that we generated for that PFX file. Next up, we create a service custom host binding using the host name value. And we're telling it obviously it needs to be on that app service or that web app. And then we also specify here that this resource being created does depend on that txt verify binding. Otherwise, without that, this could try and run first and then it ends up giving issues. And then next up, we create a service certificate binding, which links the binding by via to the certificate, which we created above on top there. And then here's that that reference that I mentioned earlier with the DNS utility from HashiCorp that lets us look up the default host name of the website and get an IP address off that. And then what we're going to do here is just show the IP that comes from that utility, as well as the URL that we were showing, and then we show the custom URL as well, which is just the HTTPS and the host name that we had specified, just so that when we're going through the logs, it's easier to browse to either the Azure Websites.net version or the custom URL version. Next up, if we go to the GitHub secrets, those secrets that I mentioned that have been passed through environment variables, we've just gone here and specified that these need to be set in GitHub. And then if we look at the action, those are passed through to the action that we've created and then passed through as environment variables to that plan. And then for demoing the apply down the line here, I've just taken off the requirement for main because we are running this off a demo branch at the moment. And then if we look at the deploy, I've just changed it to say that we're running right now off demo, allowing it to just be run without being pushed. Because we now know what that custom URL is always going to be, we can go and specify it here. So before, we wouldn't have known what that was because the app service names get generated using that random integer. Now that we know what it's going to be because we're specifying our own custom DNS, we can go specify this on our environment to say that's going to be the path when this comes up. And then for the changes that we made to the action, we have to pass those parameters through as well. And then likewise for the production environment, we go do the same thing. So let's give this a run. So I'm going to open up the terminal. And because we made changes to the provider, I'm first going to run init. Now that the init's done, we'll run the plan. And then we can run the apply. And now that that's run, we should be able to go to this old URL. I just want to grab this one so long. If we go to this old one, there we go, open that again. So this is the standard site. And if we go to it on a custom link, you can see that loads as well. So what we'll do now is just commit this code. So we're just going to say integration with Cloudflare. And we'll publish that branch. And we'll go over to GitHub. watch this run. So this should build the application without issues. It should then deploy our test site, so which should just let us be able to change that to test, and then it will deploy the test infrastructure, which lets us browse it on test. Then it will deploy the application to that test site afterwards. So we can see that infrastructure is deployed. Now if we click on summary again to look at the overall flow, you'll see that we do have that link that we added, so we can go and look at what the infrastructure looks like. See, at the moment it's busy deploying the app code, so we'll just give that some time to finish deploying, and then we'll go take a look at what that looks like. Okay, and that's run as well, and then you can see it skipped the last two stages because this is not running currently on main. So let's go click that link and see what it looks like. You can see that test site of ours is loaded. Okay, so we're almost at the end. The last part that's pretty important, specifically when you're demoing stuff, but also when you're testing stuff yourself, is to be able to destroy stuff so you can bring it all up again so that you can test it. So for this, one of the things I had to go and do is remove the prevent destroy for the resource group, and then I added a destroy.bat, which just runs an init and then an apply destroy for each of our environments, and then right at the end it goes ahead and deletes the back-end storage accounts as well. So I'm going to go ahead and run this, just called destroy.bat. All that author is already set up, so that's just going to go ahead and run for us. And the reason why you'd want to destroy rather than just delete the stuff yourself is there's a lot of stuff scattered everywhere in some instances. So like in this case here, you can see I've got the app registration, which has obviously got the federated identity as well as the service principles. And like a traditional thing of potentially just going to your resource group and saying delete the resource group means that you end up with a lot of extra bits and pieces laying around. So recently I've gone and cleaned up my app registrations because I had a lot of them because I wasn't actually cleaning up my demos properly. If you do demos yourself, the benefit of doing this destroy is that once you've run the destroy, your subscription should be in the same state as before. So you should just be able to then, after that, go and spin stuff up again and rerun your demos. So you can see sometimes the Azure portal doesn't load stuff properly. So like that app registration, it said that it was still there, but when I clicked into it, then it said actually it was missing. And yeah, the same with the resource group. I click into the resource group and it says no, it is actually missing, which is how it should have been, or how it is actually. But obviously the UI doesn't reflect the same yet. That local environment's already gone out of GitHub, and it's busy running through with the test environments at the moment and spinning down all those references. So that's finished. We should have the same, we should be able to go check the same stuff as we did with local. And you should see that it's all gone. So our environments, that the test environment is missing from GitHub. If we refresh, you'll see some resources are gone for the test group. But again, if we click on the group, it does say that it is actually deleted. It's just the Azure UI caching some of those references. and after a bit longer, our production environments will be down as well. And the reason this ended up breaking is because in my destroy script had a bat file and I referenced the PowerShell variable. So I'll just go and change that quickly to be inline, and then I'll just run that one section by itself to delete the resource script for the backend. So that's all run. You can see our resources are cleaned up a lot more. If we look at our app registrations, those should be gone as well. So you can see the test one's missing, but the production one still showed, and that's still cached. And now our backend storage is also missing. Oh, I say missing, it's been deleted. So again, if we go into resource group, it will say that it is no longer with us. So the last part to do is to commit these changes, and then we are all good and done. So great stuff. Thanks for hanging out and watching this video with me. I probably won't be posting some Terraform stuff for the next while. Start mixing it up a bit with some other content. If you have any thoughts of what you do want me to look at covering, or if there's something that I should be covering with Terraform that I haven't, that you would like to see, let me know. Otherwise, yeah, reach out to me on Twitter. Take a look at my profile page where you can find me on other places in the interwebs, or reach out on LinkedIn. Happy to chat on any of those places. Thanks. Cheers.